Welcome to Math Mini Lessons. My name is Sarah, and in this video, we're going to break down the June 2024 New York State Geometry Regents exam. Now, usually I do elementary and middle school videos and even Algebra 1, but I really wanted to push myself for this one to answer the question, can I still pass the Geometry Regents? How much do I still remember? And not only can I just remember do it myself, but can I break it down in a way that makes sense to anyone who is struggling with geometry? So that is the goal of this video. Now, this video is pretty long because it's a full breakdown of the entire test, all 35 questions, and it takes about 3 to 5 minutes for every single question. So this is what you're going to do. You're going to look in the description, the part down here on the video, and I have a link that will connect you to the test itself, and you can hit that. You can actually try out the problems yourself and then use the video to check your answers, because we have chapters here in the bottom, so you can just click onto the chapters and find the questions that you need. So I'm going to give you the answer first. If you got the same answers, move to the next one. If you didn't, stay on the chapter and I'm going to break it down for you. So this way you only watch the sections of the video that you need instead of watching the entire part, which if you want to do, great, but I really want to make sure that it makes sense to you, and sitting through over 2-hour video, after a while you're going to get tired if you do that in any sitting. Now, there's one more link I have for you, and it is right over here, and that is a link for your own TI-84 calculator on your computer. It looks just like the ones in class, so when you click onto that, you'll be able to go right to the computer, right to your calculator, and use it while you're working out any problem. So I would love to see if this is helpful for you. Please let me know if it is. I know the Regents is coming up very soon, so I want to help as many kids as we can. Now, you can share other strategies in the comments, share more questions. If there are things you want to see more breakdowns for, or other skills that you need for the Regents, just let me know. I'm happy to do so. For this video, we've broken it down just like the real Regents, so let's look at that section now. Just like the real exam, it's going to be broken up into 4 parts, and you're going to see all 35 questions. So part 1 is going to be the multiple choice. There are 24 multiple choice, each worth 2 points. So right there, that's 48 points for the exam. Then you have your parts 2, 3, and 4. Part 2 is going to have your 2-pointers. Part 3 will have your 4-point questions, and part 4 is going to be your 6-point question, and you're going to add all of those up, so just find out how many raw points you have. At the end of this video, we're going to do the conversion for your raw score to get you your Regents score. So I'll put that there for you so you can see exactly what you need to get what the bare minimum is and what the ranges are for a 1, 2, 3, 4, or a 5 on this Regents. The other things to note: you will have access to a graphing calculator. That's why I gave you a link to one in case you don't have one at home. And you may have to use a ruler at one point. And I'm going to be honest, there's one question that has a compass for a construction. I do not have a compass at home, mostly because I've been teaching elementary and middle school and Algebra 1. I could not find my compass anywhere. So I will be linking for that question, and what the answer can look like, but also I'll link another video in there, someone else's video, so you can, and a timestamp for them, like, hey, go to this minute, so that you could actually find the time that you need. And the other thing to know is the reference sheet change for starting this June. As of June 2025, this will be the new reference sheet for the Geometry Regents. Notice it's just volume formulas that all have to do with pretty much the area of the base times the height. That's for every single shape. So area of the base times the height. And one of the differences is, obviously, if it comes up to a cone or a pyramid, then you'll notice the 1/3 in there because it comes to a point. So you'll notice that as well. And for a sphere, you have 4/3. So just some notes in there so you have that in mind. The old Regents, like the one, if you look up for this exam, you would see this type of reference sheet, which had a ton more information. You had, yes, all your formulas, but you also had these here. So my note to you is these things are going to have to be memorized as much as possible. The ones that you'll probably use the most, or the ones I know I used a lot, were Pythagorean theorem. That definitely came up. I didn't have to do degrees in this exam, but just be ready in case you need any sequences. And just in case, I don't think quadratic formula is going to come up in this one, but it's something you may have remembered from Algebra 1. And I'm not sure if I didn't see any conversions really happening in this exam, but they do give you, they used to give it to you before. All right, so that's it. We're gonna jump into this part now. Remember, use the links to help you find the exam so you can take it for yourself first so you can get the most out of this video. All right, let's jump into the first two problems for 1 and 2. We have answers 4 and 2. Check off with your work. If you got the same answers or you don't have any questions, move on to the next chapter. If not, stay right here. We'll break it down. So with the first one, we have a transformations problem. And what I like to do with any type of transformations problem is to kind of annotate the figure. I like to use my notation so I can kind of see what's happening. And also I like to visualize the changes. So in this problem, for example, we're starting off with Joe. And Bree is an image of Joe. So I'm starting, here's my start. And I'm sliding up to make Bree. That's my my translation. And then it's saying take a triangle cat, there's a line of reflection. So between, here's my line of reflection. So if I were to fold it and it flips over, that is my reflection. Okay. And so what I mean by that's my visual part. So I can see it sliding up and then it flips itself over. It folds over that line of reflection. So this is really going to help me when I'm annotating. So if I'm starting off with J, which is the very first point, because it's triangle Joe, it's going to slide up to B. And notice that it's still at the bottom of the triangle. And then I'm just imagining it's flipping over to C. And this point is easiest to see. Same thing if I start with point O. It's going to slide up to R, and notice R is pretty far away from the line of reflections, and so is A. So I know it's not T, it's not a slide over, it's literally flipping itself over. Those points, if I were to fold this paper over, point R and A would touch each other, would touch. And then the same thing with E, I, and T. Now, and a lot of times when I was young, I used to go, well, what if I just wrote them in that same order? Would this always be true? So here's Bree, and here's cat, and you can kind of see here was J, B, and C were all the pinks, and then O, R, and A were all my yellows, followed by my greens. Okay, so I can see everything matching. I can see where order really matches, and I'm fine. It's really helpful for me to find those corresponding angles. Now that I have points, I can see the angles that correspond, but also the sides, because I can see between J and O, between from pink to yellow, pink to yellow, pink to yellow. Now on the Regents, you may not have colored pencils, so, and I get that. So if you need to make a different marker notation, that's fine. Because that would also help you. I just like using different colors because that really helps me. I'm a very visual person. I use my different notation from yellow to green, and here's my last notation from pink to green. And now this is really easy for me to see why R and T don't match. They're not the same color. Same thing with angles J and A. They're not the same color. They don't correspond. They don't match in my visualization. So what about with my other points, J, E, and RI? JE has 3 little notations here, and OE and RI has 2. So 3 and 2, they don't match. And you can find the one that does match is O and E has 2, and A and T has 2. That's why 4 is the correct answer. All right, let's go to the next one. And this one, oh, I kind of like these a lot because it reminds me of when we were in middle school and we did cross sections. And it also reminds me of the game Fruit Ninja, when you cut things in half. So here you have a right cylinder, and think of a cylinder, And I know that even though I can't see its 3D shape, I know the base is also going to be a circle. I can see the top is a circle, and the base is going to be the same in my cylinder. It's going to be a circle. And I'm going to cut this. A cross section means I'm just going to slice through it like in Fruit Ninja Schwa. I'm going to cut through it, and I just want to know what shape the cross section is. If I were to cut it in half, and it's telling me that it's parallel to the base. Okay, so again, remember, cross section is just what you get when you slice through a 3D shape. And when you make a slice parallel to the base, it's like cutting the shape in the same direction as the base, just a little bit higher. Like you're slicing it, you're making slices. And if you've ever helped someone in the kitchen slicing, you'll know that since you're slicing it the same way as the bottom, you're going to keep getting that same exact shape. Same angles, same shape, same everything. So the cross section is congruent to the base. It's the same copy of the base. So if you were to slice it in half, you just have another circle. None of these other ones make any sense, because why would we have a triangle if this is a cylinder? I know there's a circle at the end. It doesn't make sense. There will be a rectangle. A cone would also not make sense. I would have to cut it at a different angle in order to make any other thing happen here. But circle, this is a gimme point. This is such a gimme. Anytime you cut parallel to the base, you're going to get the same shape as the base. All right, hit pause, jot this down into your notes. Let's get into 3 and 4. The answers are 3 and 3. Pretty easy. So check off for your work if you have the same answers. Great, move on. If not, stay right here. All right, with the first one, we just have a regular hexagon. So as soon as we see regular hexagon, we know it just means that all sides have the same length, and we know it's rotating about itself on its center. And we want to know what's the minimum number of degrees that a regular hexagon must rotate on its center to carry onto itself. So in other words, turn it and make it and get the exact same image. So if we're thinking of a circle, and I was starting it and I was just rotating, one thing we all know is entire circle to make a full turnaround would be 360 degrees. With a hexagon, and this is not drawn to scale, so just imagine this hexagon is every single side is the same length. All 6 sides are the same length. I'm just going to turn it. Imagine all I'm doing is turning it, but as long as I turn it once more on this side, I'm gonna get the same hexagon again. So I just need to figure out how many degrees that is. So since we know 360 degrees would be if I did a full rotation all the way around, but I just want, let's say for example, here's this red side here. If I were to rotate it like one time, now my red side is over here, but my hexagon, it's still carried onto itself. Like it still looks like the same hexagon because all sides are the same. So I just want to know what that one turn, how much that one turn was worth. Well, I know 6 turns will turn it all the way around. So 360. And if I just wanted one of those turns, so 360 divided by 6, then I know that this is a 60-degree turn. Okay? So it would be as if I turned it one time, it would be 60 degrees, or I turned it another time. If I wanted to get all the way to back to the beginning, I would keep on rotating it 6 times, but each time would be 60 degrees. In this case, I just want to know what would be the number of degrees to carry it back onto itself to just get this one image, just a hexagon. And that one turn is just 60 degrees. All right, let's go to the next one. Now I have, let's see, a diagram. I see a sphere, and inside, inscribed, and I kind of figure it's like inside is the biggest sphere I can possibly get while being still inside the cube. That's what I'm thinking. And I can see the side length is 18. So that's important because I would also know that if the very, very top of the sphere and the very, very bottom of the sphere, if I were to just draw that line directly through it, it would also be 18. So this is also telling me if I go right through it, my diameter would also be 18. Okay, so we want to know what is the volume of the sphere. So we're going to use a volume formula. So for volume for a sphere, we're going to use the formula, and you can look it up at the, you'll always get it in the reference sheet. 4/3 pi r cubed. Now we know the diameter is 18. So what would my radius be? Half my diameter. So 9. So all I'm going to do is put all of this into my calculator. We'll sub in for r. And I want 4/3 pi times 9 to the third power. Okay, you may want, there's some kids who you maybe want all the numbers next to each other. That's fine. So I'm just going to quickly use my calculator. 9 to the third power, and I get 729. So 4/3 times 729 over 1 pi. And in this case, notice how when I looked at my answer choices, I'm always thinking, does my answer need to stay in terms of pi, or do I have to be exact? And because I already see that all these have pi in it, I know I'm going to leave pi in my answer. All right, so now I'm just going to do times 4 is 2916 divided by 3, and divided by 3 is equal to, I want to make sure I had the pi symbol in there, which would be equal to 972 pi. And that's it. I know if you wanted to, you could have just put the entire thing into the calculator, and that's fine too. I just like doing part by part, and I'll tell you why. I know a lot of kids who go and put the entire formula into the calculator, and if they make an error anywhere in there, they may not catch it because they're just going to get one answer and they copy it down. So I like to use my order of operations and just break it down and just use my calculator as I go, because it's just another way for me to double check that I'm not making a mistake. And if I do find a mistake, I can go back and I can just follow along with my steps. So that's why I don't like to do the entire like 4/3 times 9 to the third power on a calculator. I'd much rather do part by part and start with my exponent and then multiply by my fraction and then simplify it. All right, hit pause and jot this down into your notes. Let's look at 5 and 6. The answers are 1 and 3. Check off if your work. Stay here if you want to break down the problems. All right, so the key to the first one, of course, I want to start by annotating. There's a ton of information given, and usually there's some stuff that's not given that we have to figure out in order to solve the question. And for this one, we're trying to figure out what is the length of MH. So this is going to be our unknown. We want to know what is that length here. So what are they telling us? They're giving us the length of EA is 7.2. Oh, let me actually go earlier, and they're telling us that the two lines intersect, EM and HA. They're also telling us we have perpendicular lines at EA and HA. So EA and HA, so there's perpendicular, so I have a 90-degree angle here. And I also have from EM to HM, I have another pair of perpendicular lines. That's important because I know then I have right angles. So that's why I want to put that in there. Okay, so now I know what EA is, 7.2. And I also know EJ is 9. AJ is 5.4. And HM is 3.29. And we want to know what MJ is. And at first I got tricked doing this when I was practicing because I saw JM and put it in the wrong spot. That's me rushing. When we rush, we make silly mistakes. So here is the side we want to know, and we want to know it to the nearest hundredths. That's going to be important. That's telling us we're also going to round. Is there any other information? This is everything that's given. Is there anything else that we know, even though it's not explicitly given to us? Well, I see additional angles here. Angle J for both triangles is also the same because I'm thinking about vertical angles. So I know that to be true, that those two angles would be the same. And because I have two right triangles and they both have one angle that's the same, and we know that the angles all equal to 180, that's telling us that our other angles are also the same. So what we have here are similar triangles. And because I have similar triangles, I can create a proportion and solve for my unknown side. Okay, so because I'm thinking about sides, I do want to know the sides that correspond to each other. And I'm going to start with just my legs first. Like we know, we don't have to worry about the hypotenuse at all, because they're not asking us anything about this hypotenuse. So I don't really care about this line, but I do care about this leg here and this leg, the one that's opposite of J and opposite of J over here. So those two correspond to each other. And then my missing sides on the bottom. All right, so because again, I'm very, very visual, these two sides correspond to each other, and these two sides. Actually, let's make it red. Yeah, nah, we'll just put it this way. And these two sides also correspond to each other. The 9 is just there. I don't need that information. But once I have this, now I can cross multiply and solve. So what I like to do is I think very much like an elementary school teacher. So I do like to use cross products and make an equation. So we're going to multiply these two first. 5 and 4/10 times 3 and 29/100. And I get 17 and 766 thousandths. And when we cross multiply the other side, we're just going to get 7 and 2/10 x. All right, and now I can divide both of these. I know there are tons of other ways we can solve this, but I also just know that when we have calculators and tools, sometimes we just rush a little bit more in our work, and it slows me down when I can actually just write down line for line what I'm doing. All right, so when I divide by 7 and 2/10, I get 2 and 4,675 to the 10,000ths. Now we are rounding to the nearest hundredths place. So here's my hundredths, and I'm going to look at the buddy behind me, and it's a 7. So what I always tell kids when you're thinking about rounding, if it's 0 to 4, round down to the 4 to the floor. If it's more than 5, we round up to the sky. Okay, so if this was a 0 to 4, if this buddy was 0 to 4, it would round down to just 6. But because it's more than 5, we round up. So this becomes 2 and 47/100ths about, which is answer 1. All right, let's look at the second problem. I'm going to make that one a little smaller now, so I have some space for the next one. And we have an equation. We actually have a point. We're trying to find the equation that goes through this point 2, -7, and is perpendicular to this line over here. Now, that's going to be important because whenever I notice that if something is perpendicular, I know that the slopes will be opposites and reciprocals of each other. Okay, so we know this to be true. Now, so I'm going to look at the very first part, and because we already have an equation here, we have our equation y equals 3/4 x plus 4. So if this slope has, well, this equation has a slope of 3/4, then its opposite is going to be negative and a reciprocal 4/3. So we have at least the m part for the equation, remember, because we're going to try to figure out y equals for the actual equation of that line. What else do we have? Well, we have the point. We have point 2, -7. So we're going to use the point slope form equation. Y minus y1 is equal to m times x minus x1. And now I look at curve for a second. There we go. And now I can just substitute for the equation. So y minus -7 is equal to m, which we know what that is because we just said what it was, -4/3 times x minus 2. I'm going to just fix this up over here. So y plus 7 is equal to -4/3 times x minus 2. And you'll notice that that does match number 3 perfectly. Now at first I had gone further, and I had actually distributed, like I kept on going, well, this will be negative 4/3 x plus 8/3. I kept on going, and I couldn't find anything that matched that. And then I noticed when I couldn't find anything to match this, I did find that 3 matched this equation perfectly. So again, that's also why I write out all my work and I keep my thinking very visible on the page, so I don't freak out when I don't see what my solution is matching one of the answer choices there. It may be someone else in your work. All right, so I'm going to stop there, hit pause, and jot this down into your notes. Let's look at 7 and 8. The answers are 3 and 2. Check with your work. And if you want to go over these two, stay right here. We'll start with the first one, number 7. And we have everything that's given here. We know that angle R is 110. The measure of M is 40. And if this triangle is reflected over this side over here, I'm going to highlight it. Wrong side. Here we go. Highlighting over MH. There's my line of reflection. We're going to make something new. So here's my new shape. And I know this is going to be 40. Now, if I know that, because I know 40 and 110 makes 150, 180 minus 150 tells me that this last angle is going to be 30, and this angle is going to be 30, and I know this angle is going to be 110. All right, so I want to know which of these is always true. Now, the first thing that kind of popped up, number 1, why can't this be a parallelogram? Why is number 1 wrong? Here's a hint. It has to do with the angles. The angles. Because if you add up the angles over here, for full angle M, this angle here will be 80 degrees. And this angle here, if you were to add them up, would be 60 degrees. So that is not a parallelogram because I don't have, those two angles are not the same. So even though 110 and 110 are and its image are the same, 80 and 60, so this cannot be a parallelogram. Okay, because it means that my two sides are not fully, they're very, very close, but they're not fully parallel to each other. Okay, and then the second one, we can tell is wrong. Why? Oh, let's look at it. It says angle MHR is 40 degrees, and that's not true. It's 30 degrees. So that's easy. That's an easy one to spot or to disprove. And yes, we said this is the correct answer. That I like to use my pointer. That angle H, let's follow with my finger, H, M, and our new R is 40 degrees, and we can see it, 40 degrees. So that's what makes us right. And the last one, it says that MR and HR are the same. That can't be true because the opposite angles are different. So if this one is 30 degrees, it's going to have a different measure than the opposite side over here, which is opposite to 40 degrees. Okay, so there was this one was just a lot of logic, and you just had to fill in with other information that wasn't given to you that you know. That's what I love about geometry. All right, next one is the funnel problem. I kind of liked this one. It also made me think about elementary school. We have a funnel to decorate cookies. That makes me feel nice when I think about baking cookies. And we see that the funnel has a radius of 6 centimeters. We can see it right here, just the center, and the height is 13 centimeters. And the baker uses 2 cubic centimeters of chocolate to decorate each cookie. Okay, so we have a rate. Every cookie gets 2 cubic centimeters of chocolate. And we want to know when the funnel is completely filled up, what is the maximum amount of cookies that can be decorated with the chocolate. So what we need to do is we need to find the volume of our funnel, and then that's going to tell us our total volume, and then we're going to use the rate to find the maximum number of cookies. So volume, we're going to use our volume formula for this, and you could always look it up in the back part. So volume of a cone is equal to 1/3 pi r squared times the height. And now we're just going to sub in these numbers. So we know 1/3 pi, we know what r is, it's 6. So 6 squared times our height of 13. Okay, and then so we're going to start with just these parts over here. Again, you know, I like to show all my work. This part I didn't have to do on the computer. With 36 times 13, so 1/3 times 4/68 times pi. So I'm going to divide this by 3, and I get 156 pi. So now I actually have to use my pi notation, because again, notice how it doesn't just say 156 pi. There's nothing there has to do with pi, so I have to find it completely. Okay, so I have to find pi on my calculator. I found it. It was right under where the clear button is, that little pi symbol. So second and pi, and 156, and I get 490.088. Now that's the total volume, but remember, for every cookie is 2 cubic centimeters of chocolate to decorate every cookie. So I'm going to divide this by 2. And I get 245.044, and that pretty much, so the most amount of cookies I can bake. I can't bake a part of a cookie, I can do 245 cookies, which matches answer 2. Alright, hit pause and jot this one down into your notes. Again, I like to show all my work as I'm going, because it really slows down my thinking, and it makes it less likely that I'm going to make an error. And if I do, because it happens, I can follow through my work again to try and identify where the error is. Let's look at number 9. The answer for this one is 1. So the key to this one is how you're annotating and what you're seeing and what you're noticing. So we're going to start off, we have a circle O below and chords CT, and I'm going to use this. So CT and BN intersect here at point A. Chords CB and NT are also drawn. What statement is true? So there's a ton that we could actually know about this. I'm going to try and annotate with different colors so you could actually kind of see what we're talking about with these here. So the first thing you'll probably notice are we have a pair of vertical angles here at point A. And let's think about the arcs for a second. So I'm going to color in this arc. And the reason I want to do that is because when I think of this here and how it connects to this arc is the same as this angle and this arc. So this arc connects to this angle, angle B, and angle T. And then, nope, Siri, we don't need you right now. And I'm going to color this arc over here because the same thing is true. What do we notice? BCT and its relationship to that arc, and BNT and its relationship to the arc. So then, and of this third angle is also the same. Okay, and with that, we could also recognize sides that also correspond to each other. So I'm going to highlight in a different color to use pink. So for example, these two sides correspond. These two faraway sides correspond. And these two sides correspond. Now that's a lot with color, so let's simplify it. And instead, I'm just going to use, actually, I'm going to just use a different color just so you can see it. So these sides these sides and these sides. Okay, and I want to know which one of these is always true. So this is a lot with annotating, and so again, slow yourself down so you don't make a simple mistake, and we're going to follow along one by one to see which one is true. And of course, with this first one, we know the answer is correct, but let's see why. So we have a set proportion, so we have corresponding sides set proportional to each other. And I have NT is proportional to CB. That makes sense so far. So NT proportional to CB. Okay. And then the second part, TA and BA also makes sense. So this A works. But let's also check the other ones and see why they don't work. There's so many times we want to just run to the next one. You have the time. So let's just check it. We have BAC. So this angle over here and angle ATN. I'm just following with my finger. So let's think about this. They're saying that this angle and this angle correspond to each other, and we know that is not true. So the angles are actually the easiest ones to disprove. And let's look at the other one. We have NA, so from NA and TA. Okay, so these two sides got it. So NA corresponds to TA, and then we have AB, so short to AC. So that's the problem here, that we have the longest one and the short, and then here it went short and then long, so they don't match. So that one's a little tricky. That's the trickier one to see when you're working through it. So again, just so you can see it, TA and A would be this nice long side, and TA is short, so it's going long to short, and then on the other side is going AB, which is short, and then AC is long. So that's why they don't match. And the last one we have BCA, so angle C. Actually, I want this part. So angle C and angle T. And we can see they also don't match. So yep, one is the best choice. It matched perfectly, and the other three were incorrect. Hit pause and jot this down into your notes. Let's look at numbers 10 and 11. The answers are 1 and 2. Check off with your work and stay here if you want to see the explanation breakdown. For the first one, we're going to use a ton of algebra here because we have some triangles, and we're going to use our facts about triangles and interior angles. So we can see triangle ABC. Let's make it a little bigger. Here's triangle ABC, and we see that this ray is drawn and it bisects at AB. Bisects angle ABD. Alright, so here's this angle, and this line bisects it, which means that these two angles are the same. They have the same measure. And that's going to be important. And we have BD and AC are perpendicular, which is why we have two right angles over here. The other information we have is angle C is equal to 42 degrees. And we want to know what angle A is. So that's our X. All right, so at first, obviously, I'm thinking I can use something I know about triangles. Could I figure out the interior angles of these triangles? At least I have one angle. If I could figure out what this angle is, I can figure out the angle for this bigger triangle for angle A, or even if I knew I have this angle, if I can figure out what this angle is, I can figure out what X is. So I'm going to start by figuring out this angle over here. So I'm going to start by just filling in what I can figure out, and I want this angle. So what I'm going to do is I'm going to do 180 minus 42, and that's going to give me 138 degrees. And I'm also going to subtract the right angle 90, and I get 48 degrees. So this angle here is 48 degrees. Now, that's good because I know that this is a straight angle that equals 180 degrees. So if I do 180 minus 48, I get 132 degrees. These two angles have to equal 132 degrees. And I know that these two angles are exactly the same because it bisects. That means this angle is cut directly in half. So if I just take 132 and cut it in half, I get 66 degrees. So this angle is 66 degrees and this angle is 66 degrees. And that's awesome because now I have this angle and this angle. I can find out what angle A is now. So I can just do my usual, and again, so many different ways of representing this. Some kids write down the inquiry equation, like they might do 90 plus 66 plus x equals 180. Some students just do it in piece by piece, whichever way you want to do it. Since I was just starting this way, I'll keep it going to figure out what x is equal to. 90 plus 66 is 156 plus x equals 180. If I subtract 156 from both sides, I'm going to get x is equal to 24, which is A. Alright, so it's just using triangles and some basic algebra in order to solve. Let's look at the next one. We have a circle. It has a radius of 6. We have the angle given is 100. We want to know what is the area of the shaded part. Of just this part. So I want to know part of a circle, the area of part of a circle. Okay, so anytime, I remember in elementary, middle school, when we wanted to know a part of something, we would usually multiply. And I know that this angle is 100, the entire circle would be 360. So this angle here would be 260 degrees. So what part of the circle is that? I can represent that part as 260 over 360, that part out of all 360 degrees. And we can multiply that part by the area of a circle. And the way I remember area of a circle formulas, I go cherry pie, delicious, that's circumference. Apple pies are 2. You'll have the formula, but I like to have it memorized. So for the area, I would do pi r squared, and we know what pi is in this case. We know what r is in this case. It is 6. Okay, so let's keep writing this out. So 260 over 360 times 36 over 1 times pi. That's going to give us the area of the shaded part. So I'm going to do 260 times 36 is equal to 9,360 over 360 pi. So let's divide it by 360 and we get 26 pi, which is equal to 2. All right, hit pause and jot this down into your notes. Here are the answers for 12 and 13, 4 and 4. All right, we're going to start the first one. In rectangle ABC, diagonal AC is drawn. So I need to visualize that. Oops, to get my pencil. Now remember, I'm writing it in order A, B, C, D. I can't tell you how many times when I was first writing this, I did A, B, C, D. It was a habit I had to break for a long time. Here we go. A, B, C, D. And we have diagonal AC is drawn. The measure of ACD is 37 degrees. So we know this angle here, 37. We want to know the length of this side to the nearest tenth of a meter. What other information do we have? We know the length of BC is 7.6 centimeters. Okay, so because this is a rectangle, we know we're definitely dealing with a triangle, and that means we're going to have some trig functions. We have a right triangle here. Because it's a rectangle, I know this side is going to be the same. So this is 7.6 centimeters. We know that this angle over here is 37. And I want to know h, which is my hypotenuse. Okay, and I know that 37 is opposite the 7.6 centimeters. So you're thinking of your whole SOHCAHTOA. And we notice we have an opposite and a hypotenuse, so I'm going to use this ratio over here, this trig function. Sine is equal to opposite hypotenuse, so we know that sine 37 is going to equal the opposite length, 7.6 over h. Now, I've seen a lot of kids just go and say, like, I can just swap this, and they don't remember why. And what I mean by that is they end up going x is equal to 7.6 divided by sine 37. A lot of kids just go, it's just switch, like they just, you know, switch each other out. Why does that actually happen? It's actually just some middle school math. Like if I had this over 1, and it would be my cross products, I would have, like if I just multiplied across, and you've seen me do it a few times in this video, this would be 7.6, and if I multiplied this side, it would be sine 37 times x. And to get the x by, what would we want to do next? Sine 37x is equal to 7.6. I would just end up dividing by sine 37 on both sides, so I will have x is equal to 7.6 divided by sine 37. Okay, that's where it's coming from. But if you still need to actually write that out, you can. But now this is something that I can solve, and you're going to have to use your calculator for it. So you're just going to make sure your calculator is in degrees, and you're just going to put 7.6 divided by sine 37, and you'll get x is equal to 12.628. We want to round to the nearest tenth, so here's my tenth. Here's this buddy. It's, remember, 0 to 4 round down, so x is about 12.6 centimeters, which is 4. All right, let's look at the next one. The next one, we have a cylinder jar, and we have the volume, and we have the height. We want to know what is the diameter of the jar. Okay, so we're going to do volume of a cylinder is equal to, is pretty much always the base of whatever figure you have times the height. In this case, we have a circle. So remember, apple pie delicious, cherry pie delicious, apple pies are 2 times the height. And we have some information already. We know what the volume is. We know what the height is. Now we just want to figure out what the diameter is, and we can find that once we find the radius. So we're just going to substitute all the information we have, and we're going to use our calculators for this one. So being that our volume is equal to 1,180 centimeters cubed, our height is equal to 10 centimeters. Pi I'm not too worried about. And we also know that diameter is equal to 2 times our radius. So we're going to start with that. Okay, so let's plug in. So 1,180 is equal to pi times, we have no idea what r is right now, r squared, times 10. I want the r by itself, so on this side I'm going to divide by pi and 10, because I want these to cancel out and just leave me with the r squared. And that means I have to do the same thing over here. I'm going to divide by, I'm just going to put 10 pi. So I want you to be super careful. There are 2 ways we can actually type this into our calculators. One is I can put 1,180 divided by, and I'm going to use parentheses for 10 pi, because I want the calculator to know for sure that these are together. and I get 37.5605. Okay. The other way you could do this, and I almost never type the fractions in here, almost never do it, but you could do alpha y equals 1 and just put 180 and then go down and write 10 pi. You'll get the same answer. Either of those will work. The reason why we don't do it the other way is because sometimes calculators will read it as 1180 divided by 10 and then multiplied by pi. And see, that will give you a completely different answer. So just be wary of that. All right. Okay, so now we have all this part. I want to figure out what r is. So I'm going to find the square roots of both of these to find r. So let's do second square root. I'm going to retype the same thing I just had because I realized I didn't have the answer part anymore. So 5605, boom, and I get 6.1286, and I'm going to double that because I want the diameter. So this is my radius. My diameter is 12.257, and I want to round it to the nearest tenth. So here's my tenth. Look at the buddy. That means I'm going to round up. My diameter is about 12.3 centimeters. Okay. And there we have it. That was a lot of work, and I definitely want to make sure that you know how to use your calculator and not to fall for those really small mistakes that can happen when we're just using the calculator, because guess what? It's a tool, and it is trying to understand what you want, but there are times when its reading of the expression may be different than what you intend. So I wanted to make sure you understood that part. All right, nevertheless, let's hit pause and jot this down into your notes. Let's look at 14 and 15. The answers are 3 and 2. We'll jump into 14 first. In this case, we have a triangle. KLM is dilated by a scale factor of 3 to map onto itself. So what does that mean when it's dilated? It's either getting bigger or smaller. In this case, it's getting bigger because it's a whole number. So if it was dilated by 1/3, I know we'll get 1/3 smaller. So in my mind, I see this. I see KLM, and then it gets dilated, it gets bigger to make DRS. So I'm kind of seeing this times 3 happening. So I want to know which of these is not always true. So let's think about the other ones. In the first one, we have point K corresponds to D. Yeah, that's always true. Always, no matter what. In the second one, we have KM is 1/3 the size of DS. Well, yeah, that makes sense because it'll say KM is 3. On the other side, if it's 3 times bigger, then DS would be 9. If KM is 10, it's 3 times bigger, the side would be 30. Even if I had a fraction, if this was 5/10, then times 3, this would be 1 5/10. So this is always true. KM is 1/3 the size of DS. So that makes a ton of sense. So in 3, the area of DRS is 3 times the area of KLM. Why is this not always true? So let's say, and I'm going to come up with a simple situation. Let's say this is a very simple triangle with a base and a height of 1. And here this is going to have a base and a height of 3. So the area for this side would be 1 times 1, base times height, divided by 2. So base height divided by 2, which is 1 times 1 divided by 2. So the area for the side would be 1/2. So if 1/2, if it is 3 times the area of the other one, 1/2 times 3, then that would mean that this one would have to be 3/2 or 1.5, right? Is that true? Base times height divided by 2 would be 3 times 3, or 9, divided by 2. And that is not the same. So just looking here, this is a condition where it is not the same. It is not always true. And that is why 3 is the correct answer. But what about with perimeter? What if I had the perimeter parts? I'm going to just use a simple, would that always be true with the perimeter? And let's say, and I'm just going to randomly, I don't like to randomly make numbers, to be honest. But let's say I had 3, 4, 5 on this side, and then I would have 9, 12, and 15 on the other side. The perimeter, and for this one here, would be 7 plus 5 is 12. And I would assume that then the other perimeter would be 36. So 9 plus 12 is 21. 21 plus 15 is 36. And that makes sense. That would be 3 times bigger because each side is 3 times bigger. So I'm going to have 3 times each individual side, which would make the overall perimeter 3 times bigger. Okay. I kind of found that this was the trickier one too, when it's 1/3 DS, because it makes me think that KM is the bigger side. I can see kids thinking that, or students thinking that, but that's not what it reads as. Let's look at 15, and this one is another great one for visualization. When we think of it, we have a rectangle with a dimension of 4 by 5, so 4 by 7, and it's continually rotated, like kind of like I stick it on my pencil and I'm spinning it around. About one of it's continually rotated about one of its 4-foot sides. So like pretend this is my pencil and I'm spinning it around. I'm just spinning it. Okay, so if you spun it around and spun it around, you kind of imagine it kind of just spinning around as a 3D shape. Here's my pencil. Okay, so now they're asking us the resulting 3-dimensional object is. So what would you have there? So because I'm spinning it and spinning it and spinning it, I'm going to end up with a cylinder. So I'm definitely not ending up with a cone. But spinning it, I'm coming up with a cylinder shape. You can see it. So now which one is it? Do I have a height of 7 and a radius of 4, or a height of 4 and a base of 7? Well, we know this part here was 7. The height is 4. And that stays consistent. So my height is 4, my radius is 7, and my diameter is 14. So which is true? My height is not 7. So this one has to be wrong. My height is 4, and the base radius is 7. So my answer is 2. But I wouldn't have gotten there if I couldn't see the picture in my head. That's one of the things about geometry. It really helps when we can see it, visualizing it, and draw it out. All right, hit pause and jot this down into your notes. Let's look at the answers for 16 and 17. And these two really stretched my brain. So for 16 and 17, we have 4 and 3. And so let's jump into it. If you didn't get these answers or you're not sure why, we'll start with the first one. And my first challenge with this one was being able to draw it, because what we actually have here is an altitude drawn from the right angle of a hypotenuse. And how do I know that? It's because it says altitude CD is drawn to the hypotenuse. So I had such a hard time at first trying to draw this, because I oftentimes, when I think about my right triangles are here, and here's my hypotenuse. But in this case, that my altitude, like if I had a line cut through, that's not an altitude. So it looks more like this. So here's my right angle. Now here's my altitude from C to D, and my hypotenuse A to B. And what we have here, again, we have an altitude from the right angle to the hypotenuse, and this is going to create 2 smaller right triangles. So I have one here and I have one here, and that means I can get some geometric proportions going on. So what else do we know in this problem? We know that AD is equal to 4. We know that CD is equal to 8. So like the legs of the smaller right triangle. But I want to know what this side is equal to over here, this part. So again, I have 2 right triangles now. I have this one, and I have this one. So there are two ways I can kind of represent this. So one way to represent this is to use the altitude rule, which would just say in this case, it would be my altitude. So I'm going to do one-way altitude rule, which says my altitude, which is normally written as h, which was super confusing when I was a kid because I would always think of hypotenuse, is equal to the product of the two parts. So in this case, we would say part 1 and part 2. And so oftentimes they will say, like, they will call part 1 P, part 2 Q, and you can find it that way. So it would be the altitude squared is equal to the product of the two parts here. So you would just say 64, because that's my altitude, is equal to 4x, and then you would just do 64 divided by 4, and you would get 16, which is the answer. So that's one way. The other way is you can actually create a portion where you can say the altitude over part 1 is equal to part 2 over the altitude, or 8 over 4 is equal to x over 8. And you're still going to cross multiply and get 64 is equal to 4x. Doesn't matter each way. And you're still going to get x is equal to 16. So the big key for me was being able to recognize how to draw it and recognizing that the altitude was cutting through the hypotenuse, which means my 90-degree angle had to be on top and it's being cut. All right, let's jump into the second one. If parallelogram ABCD, and that just means quadrilateral, 4 sides, 2 parallel. So it could be like a rectangle like this, could be like a square with parallel sides, it could be one that looks more slanted, does have 90-degree angles. And they want to know which is enough information to prove that ABCD is a rectangle. So the answer for this one is 3. I'm going to show you why. So here's A, B, C, oops, and see, I did it again, C, D, and it's telling me my diagonals AC is equal to BD. So because they're congruent and because those two diagonals are equal, I do have a rectangle. If my diagonals are, let's see why the other ones are not true, because in this case these are perfectly equal. It would be like if I had a right triangle here, and if I had a right triangle here, these two sides would be the same. Obviously these two sides would be the same, so my hypotenuse or my diagonals will both be the same. So why don't the other ones work? So AB is equal to BC. That would not be true in a rectangle. If they were the same, it would be a rectangle, but it would particularly be a square. This would only be true if my rectangle was also a rhombus, particularly a square, not even just a rhombus, a square. Okay, so that doesn't work for all rectangles, not enough. For the second one, 2AB is parallel to CD. Is that enough? Well, just having one set of parallel lines doesn't make a rectangle. It could be a trapezoid. Like I can have a trapezoid with one set of parallel lines, and I can have a square or rectangle with 2 sets of parallel lines, but only one set. It could be a parallelogram if the other 2 sides are parallel, but at most this is a rhombus. I'm sorry, a trapezoid. That we would know for sure because there's one set of parallel lines. All right, and we already talked about 3, so what about for 4? AC is, here's AC, is perpendicular to BC. Ooh, let's talk this one out. When would this happen? Well, it's not happening here because here I have 2 sides that, I have a true rectangle with one set of lines that's longer than the other one. So this is not making. But when would that happen? So I like to just draw it out first, and let's imagine. And then I can just connect these. So in this case, I have a, does it make a perfect? In this case, I have perfect lines here, but that's not, it's not true for all rectangles, or even if I had, let's say I made these longer, and now this isn't a rectangle. So here I have perpendicular lines, but this is not a rectangle. And here, even if I twisted it, because it actually is a rectangle, it only definitely works if it's a square. So this is only square only. So it's not enough, but the only true one would have to be 3, where my diagonals are equal in size. Alright, so this is another one where a lot of logic, a lot of trying things out really helps. So hit pause and jot this down into your notes. Let's look at number 18, and for number 18 the answer is actually 1. And we're only going to look at this one in this chapter here. So there are 2 ways we can solve this. One I find way easier, so I'm going to show that one first, and then I'll show the second one, which I think is more complicated because it involves another formula. Okay, so here we have a line segment. APB has endpoints at A and B. They give it to us, and we know the coordinate of P if AP is to PB is a ratio of 1 to 3. So let's just kind of graph this out. And yes, you can use some graph paper in the back. I'm just going to sketch. So my first point is -5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So here's point A. And point B, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Here's B. That's 7, -4. Okay. And I'm going to draw a line between them. Not perfect. There's A to B. Now somewhere between A and B is point P. And what we can see is that from A to P, let's say if P is here, from P to B, this side it has a ratio of 1 to 3. So in other words, like whatever the distance is from this part, it is a third the size of this part. It's almost like, but together they would make 4 equal sections. So how do I find out where P is? So when I first started thinking about this, I started thinking of, well, what is the distance between this? Could I figure out what A to B is? And I started thinking automatically of my little triangle to figure out the slope, and I noticed I'm going down 8. So here's y4 to 0, that's 4, and down another 4. So that's -8. And then I'm moving over from -5 to 7, so this distance is 12. So my slope in this case is -8 over 12, just to get from A to B. And I was thinking about it, and I was like, so if A to B, here's A, here's B, and it's almost like I'm splitting it in half and then half again to find P. So this is 1 part to 3 parts. So could I, so there are 4 equal parts, could I just divide this by 4? And yeah, if I simplified this slope, I would get -2 over 3. In other words, if I just went down 2, so if I went down 2, so 4, 3, 2, and over 3, 1, 2, 3, I would be at this point here, which would be -2, 2. So that's just one piece. And if I did it again, if I went down 2 and then over 3, 1, 2, 3, the point would actually be over here, which would be 1, 0. And then I went down 2 again. 1, 2, and over 3, 1, 2, 3. My other point would be 4, negative 2. And then if I went down 2 again, that would be negative 4. So I'm negative 4. And over 3, I would be at 7. So here are all my points. So then P would be this one over here. P would be at 2, negative 2. So that's kind of the way my brain was thinking about it when I was thinking about the whole line and what the ratio meant, which to me made sense, but I recognize it wouldn't make sense to everyone. So what you could do is you can also use this formula. We're using the points. So we can put in, for example, or point x. X is equal to x1 plus p over p plus q, which here's our parts, our ratio. So p and q, or 1 and 3. You can put that in. And then x2 minus x1. And we can do the same thing with y. Y is equal to y1 plus p over p plus q, our parts, and y2 minus y1, our change in y. So for x, we can put our x1 is negative 5 plus our p in this case would just be one part over 1 plus 3 times y2, which is 7 minus negative 5. So some people find this method so much easier. I find there's so many places to make mistakes. So negative 5 plus 1/4 times 12. That's what we have so far. So we have, let's keep going in this one. So 5 plus 1/4 times 12. Okay. I'm gonna just multiply. All right, 5 plus 1/4 times 12. So I'm gonna multiply the 1/4 times 12, and I get negative 5 plus 12 over 4, which is the same thing as negative 5 plus 3, which is negative 2. All this to get to negative 2, which was the x coordinate I already had in the drawing. And now I'm going to do the same thing with the y. So I have 4 plus, I already know this is 1/4, times our change in y. Y2 is negative 4 minus 4. Again, I already know we go down 8. So 4 plus 1/4 times negative 8. 4 minus 8 over 4, which is the same thing as 4 minus 2, which gives us positive 2. So that's our y coordinate. Y is equal to 2, and x is equal to negative 2. And so our new coordinate becomes negative 2, 2, which is still the answer for 1. So that's what the actual formula. Again, this made a ton more sense to me when I did it, but I get that some people may find this formula and doing the algebra easier, as long as you are very careful, as long as you take your time, don't get mixed up with adding and subtracting with positive and negative numbers. And this part I find to be very tricky when you're just multiplying by the fraction. So please make sure you're multiplying before you add these two together. All right, hit pause and jot this down into your notes. Let's look at 19 and 20. The answers are 3 and 2. So going off with 19, we have our diagram set. We know that two lines A, B, and CD intersect at E, and that ACA and DB are drawn. We know that CA and BD are parallel to each other. We want to know which do we know is always true. Well, we know that here, because of the way they're cut, these two are vertical angles, so they're going to be they're going to be congruent to each other. And because we have parallel lines cut by a transversal, which is cut, let's see, CA and DB are drawn, AB and CD intersect, we could say that if this is also a parallel line cut by a transversal CD, we have some alternate interior, alternating angles. So for example, angle C and angle D would be congruent to each other, and the same thing for A and B. And so what we have here is, at least we have two similar triangles. I don't know for sure about the size, but we do have, because of the angles, we do have similar triangles. So that's why 3 makes the most sense, that they're similar to each other. There's just not enough information to say for sure that the sides are congruent in the other choices. So A and E and B and E, we can't say for sure because we don't have enough information to say that these are congruent or these sides are congruent, or to say that these two triangles themselves are congruent. Although they have corresponding sides and congruent angles. Let's move into number 20. If sine 3x plus 9 degrees is equal to cosine 5x minus 7, what is the value of x? So I noticed off the bat, because of sine and cosine, that these are co-functions of each other. So because they're co-functions, the angles are complementing. Okay, so let me just put this in. Co-functions, and automatically I think they complement. That means they add up to 90 degrees. So if I were to put them together, 3x plus 9 plus 5x minus 7, they would equal 90. Now it's just algebra and I'm solving for x. So 8x minus, I'm combining like terms here, minus 2 is equal to, plus 2 is equal to 90, because positive 9 minus 7, you get a positive 2. Subtract 2 on both sides. 8x is equal to 88. Divide both sides by 8. X is equal to 11. Notice how when I'm rushing, because this is one of the quicker ones, it's so much easier for me to make a mistake because my mind is rushing through. So this is why I constantly remind you and have to remind myself, slow down. Just slow your thinking down. Make sure you're jotting everything down. You're less likely to make mistakes when you can slow down your thinking. Here we go. X is equal to 11. Hit pause and jot this down into your notes. Let's look at 21 and 22. 21 is 4 and 22 is 4. 21 has to do with the angle inequality theorem. And that pretty much says the two smaller sides, if you add them up together, the sum of the smaller sides will be greater than the third side, or the biggest side. That's it. So in these, that's the only way we would have a true triangle. So when I look at number 1, I'm really looking, are the two smaller sides, when I add them together, bigger than 3? Is that true? Nope. 1 plus 1 is not greater than 3. 2 plus 2 is not greater than 5. 3 plus 3 is not greater than 6. It's equal to 6. But 4 plus 4 is greater than 8. So the answer is 4. For 22, we're back to the same altitude problem. So let's really jump into some of the things here, and I'm going to use some of the terms and letters for some of the proportions that we'll have here. What we're looking for is we want to find out which equation, which proportion can help us find side AC. So this side over here, that's our X. And so let me just start by just drawing this out again. It really helped me when I thought about it this way and when we were thinking about it before. So we had our altitude, which I said I was so confused that they called it H. That's my altitude, because I was used to seeing hypotenuse as the altitude, and it's cutting right through. There's my 90-degree angle. So we have these two parts, P and Q, That's the two sections of my smaller triangles. And if I add P and Q together, I get my hypotenuse C. So C is the hypotenuse. That used to drive me nuts when I would try to remember it. All right, and then you have your smaller size, the other two legs, which we'll just call, in this case, we're gonna call them A and B. So here's A, here's B. Now in this case, we're trying to figure out this side over here. That's the one we want to figure out. And so the ratio we would have is that side is proportional to, I have it crossed, they're going to cross, so that's how I'll get my A squared. And then we're going to have a part, get my highlighter, a part to whole. Okay, the product of the parts to the whole thing. So in other words, P to C. Instead of just saying P plus Q together, we're gonna just put C. All right, so it will be the product of C and P, the part times the whole. Okay, so now let's actually use some letters that we have here. So again, if I want to find this part over here, this AC, we could put AC and AC over here, because that is going to be A times A squared. And then we want the part. What's the little part we want? This part here, this AD, times this whole thing AB. Okay, so you're going to look for something at the AC, and the AC is going to be the first dead giveaway. So when I was looking at this at first, I saw here's AC, here's AD, so I know this can't be it. And here's, these are opposite each other, AC and AC, so there's something there. But notice how CD, this part here, this is my altitude. I don't want that. So let's look at the next one. We have AC and BC. Nope, can't be it. And I don't want you. We do have our ACs. When we cross multiply them together, we are going to have AC squared. We want that. And then we have our, see if the other part really works. Look at my pointer. AB, which would be the whole part, yep, times AD. So, yep, that would give us our AC squared is equal to AB times AD. So that is the one we want. So I hope this one makes it easier. I realize I didn't explain all the different proportions in the last one, but here's one when we want to find the actual legs, like one of these two legs up here. Hit pause and jot this down into your notes. Let's look at 23 and 24, the last multiple choice problems. The answers are 1 and 1. Stay here if you need help with either one of these. For the first one, we're looking for a statement that really proves that two parallelograms for MARK or mark is a rhombus. So when we have a rhombus, it just means we have all four equal sides. So automatically my brain thinks of the two examples, which would be a square. And I actually sometimes try to draw these equally so I can also have this rhombus. Okay, so one of these two. So the problem with 3 and 4 is it's just not enough information to say that we have a rhombus. So let me put in, here's mark, and I'll put this in these two examples, mark. And in the first one, it says angle K and A are congruent to each other, or K and A are opposites, angles. That's again not enough to prove that I have a rhombus. I can draw a shape where the opposites are the same, and then I can make the other two sides. I can make them smaller or even larger than each other if I extend them out. So for example, if I extended, it's just not enough information here to say that's true, because I could, what if I had a rectangle, for example, and these two are the same, still not a rhombus, so that doesn't work. And A and R can be the same, but that also doesn't tell me anything, because I can have, for example, a trapezoid or with two right angles, and that would also not be a rhombus. So I can think of examples that can disprove those. So now let's look at the sides. So I have MA is equivalent to MK. So this tells me something. So if these two sides are the same, that can be enough, because it's telling me I have a parallelogram, so I already know that the opposite sides are also, if these two are the same, then I know that these two are also going to be the same, the opposite sides. So that is enough. So why doesn't 2 work? So in 2, I have MA and KR are equivalent. Again, I could just have a rectangle. And here MA and RK are equivalent to each other, but that is not a rhombus. So that's why 2 doesn't work. With 24 was actually a lot of fun when I thought about it, because let's look at what it's asking. It says a line has the equation y equals negative 2x plus 3, and it's dilated. So just imagine I have this line, and my line y equals negative 2x plus 3. Okay. So positive 3, 1, 2, 3, down 2 over 1, down 2 over 1. So here's my line. Let's say this is my line. And it's dilated by a factor of 4. So it gets 4 times bigger. So my line gets bigger. My equation doesn't change. So just because my line got longer, my slope is still the same, and my y-intercept is still the same. So my equation does not change for the line, even though it dilates. So that's why the answer is 1. I can see a lot of kids picking 2 because they're just multiplying the 3 by 4. So 3 times 4 and getting 12. So I can see why kids would do that. But again, that would mean that now my intercept is way up here. So that doesn't work. And if I do anything to 3 and 4, these are changing the slope. So now it's not the same line at all, because now my line has a much steeper slope where it's going down 8 over 1. So it's rapidly going down. So that can't be it. So that's it for multiple choice. Just looking at it, if you were to add up all your multiple choice ones, you can count them up, see how many you got right, and you can multiply that by 2, and that will give you the number of points for part 1 of the test. We're now going to start jumping into the constructive response. Let's look at the first 2-point problem. They've given us most of the information already on the diagram. We know that angle C is 90 degrees, AC is 11, AB is 18. We need to find and determine what angle A is to the nearest degree. So this is what we're trying to find, this part over here. So from this angle, what do we know? We can see 11 is the adjacent, and we know 18 is the hypotenuse. So if you're constantly saying SOHCAHTOA to yourself, then you're using this one over here. So the cosine of A is equal to the adjacent over the hypotenuse, or cosine A is equal to 11 over 18. Now, how do we find cosine A? We're going to have to find its opposite. So A, the measure of A, is equal to, we're going to find its inverse using the calculator. I'm going to type all this in, and our adjacent over hypotenuse. So on my calculator, I'm going to hit seconds and cosine. So there's my inverse. And then this 11 over 18. And that gives me my measure of angle A is exactly 52.3300, whatever. It goes on and on and on. But I want the nearest degree. So we're going to round. Here's my number. It's a 3, so I'm going to round down. So measure of angle A is about 52 degrees. All right, hit pause and jot this one down into your notes. All right, let's look at number 26, and this is a construction, and I'm going to be completely transparent and honest. Working on my iPad and with, I use Notability. I only get certain tools, so if I have a ruler, but I don't have a compass feature. So I can't physically draw this using my iPad, and unfortunately, usually I would just put on my camera and show you on a whiteboard or on paper, but I actually don't have a compass here at home. That's where I do all my videos and my homework. So I wasn't able to create a construction. So what I am going to do is I will link a video that another teacher has done with a compass, so you can see how to do it. And I'll put the timestamp on, so that way you're not missing out on what this construction could look like. But I'll also give an example. This is an example of a full 2 credit point where, and it's really weird to try and explain, like if this was my starting point. So let's say I started here with my compass. I would end up drawing, like I would move it to draw my other marks. So I would be able to make my other marks, and then I would just move the compass over and I would shift to this part to make my other marks. And so you would have these 6 marks, and I'd move it. Let's say now I put my compass here, and I'd move it and make a mark here and make a mark here, and then I'd move it over and it would make a mark here and it would make a mark here, and I'd move it over. So it's really just hard to visualize, but you would end up having these 6 marks. And I know that to make a triangle, I would just need 3, especially to make an equilateral triangle, and so that I would just choose 3 in the middle. But for the level of precision, again, I want you to actually see someone as they're drawing it, because it's one thing for me to say it, it's another thing to see someone do it in action, and I want you to feel prepared. So go to the description, look at question 36, and you'll find a link to another video of another awesome math teacher. And if you look at just that timestamp, you'll be able to see how they construct this problem. All right, let's look at number 27, quadrilateral deer, and I want to figure out what series of transformations would have mapped it to my second set over here. So one thing you've probably already noticed is that if I'm following deer this way, I'm going in this direction, and here I'm going in this direction. So I absolutely have a reflection happening. So there is a reflection, and I have some type of translation because it has slid over. So does the order really matter? It does, but both answers are correct. So let's say you started like me. I actually did a slide first, and then I reflected. So let's say you started with a translation, and then a reflection, versus a reflection and then the translation. And I like to start with like just focusing on a point. So let's say I started at D, and how did I get from this D to this D? Well, in this case, I would have gone over 2 and down 7. Okay, and if I would have done that, I would have mapped out all my points and done the exact same things here. We're going over 2 and down 7 to each and every point. So let's just draw all of those in. So here's E, here's A, and here's R. So here's my shape, and then I would have flipped it right here at this line, there's my line of reflection, and that would have been where x is equal to positive 2. So that's one way. So does that mean then that this would have just been x equals positive 2 and then 2 negative 7? Does that mean the same thing? Let's actually test it and see. So I'm going to erase my parts. And we're going to start with the reflection first. So how would I get, I'm going to reflect it first, and I'm going to reflect it here over my y-axis. So my d is going to stay the same, and now it's just my other points that are changing. So here is E, here is A, and here is R. Okay, so and then from there, what would I have done? I would have still moved over 2 and then down 7. So this part does stay the same, but not this. So here this would have been a reflection over the y-axis. And then the translation of 2, negative 7. Alright, either way will work, but in both cases there's your series, your sequence for reflection and translation. Let me know if you found another way of mapping deer, quadrilateral deer, to the other location. Alright, hit pause and jot this down into your notes. Alright, let's look at 28. We have circle P and we have tangent AL and secant AKE. We have some information here, so let's type it, let's put it in. We have AK is equal to 12, KE is 36, and we want to know this side here, the AL. Now, so when I'm looking at this one here, I'm thinking a lot about relationships between these, and I can tell this part over here, it's my tangent, it's completely out. And if I was thinking about these ratios before, let's say I had something like this with a circle, I would think a lot about the parts that are on the exterior and the entire part over here, the entire segment. And I would think about these relationships, and I would just do, for example, I will say my segment times the exterior is equal to segment times exterior. But in this case, so for example, just so you can see it in this part here, I would think of my segment, this whole part here, the 12 plus the 36. Being multiplied by just the exterior part, the 12. So this is 48 times 12, which would give me 576. But on the other side, there's only the exterior part, there's nothing else. So in here, I'm going to put my tangent squared. It would just be my tangent times my tangent, which would be my tangent squared. Or another case in here, it's just x squared, because I just have x times x. You know, just so you can see where I'm getting from x times x, or just x squared. So x squared is equal to 576, and I would find the square root of both. So x is equal to square root of, let's find it, and then as soon as I start typing, I'm like, I know this number. I felt lazy. X is equal to 24. I knew the square root of 4 of 576. It happens. All right. So that's kind of what I had to remember. I had to think about those relationships here. And what really I had to remember was, because this is the only part I have, I'm just squaring. I'm doing that tangent, x times the x. Tangent times tangent, or in this case, x squared. All right. Hit pause and jot this down into your notes. Okay, for 29, we have the equation of a circle, and we want to determine the coordinates of the center and figure out what the radius is. So I've already started by rewriting the equation, and I'm going to move the 7 over. I'm going to subtract 7 on both sides, so that here I just get x squared plus y squared plus 8x minus 6y is equal to negative 7. And let's put my x's next to each other and my y's next to each other. And from here, what I'm going to do is I'm going to complete the square so that I can write this in a nice way. And if you've seen my other video on Algebra 1, you know that for completing the square, I like to do the little visuals for it. If this is my square x, I would do the half 8, so I would split half it here, so 4 of them would come here, so plus 4, and the other 4 would come here. And then what's missing on this part here would be what? It would be the 16. So 4 times 4 would give me over here, I'd have to add 16 in. Okay, so because I would do that, but then I can get the number I really want, which is x plus 4 squared. Now, because I'm adding 16 here, I'm going to add 16 here. And I'm going to do the same thing to the other side. Here's y, and I'm going to split 6 in half. So here's negative 3. And over here is negative 3. So, and so what's the missing part of the square? 3 by 3 would make 9. So I would get plus y squared minus 6x plus 9. And again, if I'm adding 9, I'm going to add 9 over here. And I want to do that so that I can get this number I want, y minus 3 squared. So all that is equal to, make sure, don't forget this negative sign, it happens, negative 7 plus 16 plus 9 is 25, and negative 7 plus 25 is 18. Okay, so this is what I want so far, and I want this because now I have it into this form, 8 minus h squared plus y minus k squared is equal to r squared. Okay, so now that we have that, we know our center would be hk. And in this case, our center, so we can see here, remember I want it to be minus h. So if we have 4 here, it will be minus 4 positive 3. So that's our center. And our radius would be the square root of 18. So you could leave that, but if you wanted to split this up, you would get 3 square root 2 is equal to r. So there you have it. Now we have our center and we have our radius. I love doing completing the square this way in this visual model, so I hope you find that helpful too. But it also helps to remember, let me bold it out. This is the form we want to end up with so that you can find the center and its radius. Hit pause and jot this down into your notes. Let's look at number 30. We need to figure out the area of this triangle. And first thing I did with this one is I started just drawing the box around. Let's put this triangle in this rectangle because we can find the area of this whole rectangle. Just for this top part up here, we counted off 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has So this is a 9 by 1, 2, 3, 4, 5, 6, 7, 8 by 8. So the area of the entire part is 72. But I just want my triangle. So what I'm going to do is let's find the area of just the little pieces of these little smaller triangles that we've just created. Because now I have a base and height, I can figure this out. So for example, the area for this one would be 9 times 8 divided by 2. Oh, sorry. I made a silly error. So the 8 is my entire side. But just from here to here, I just have 4. So 9 times 4 divided by 2. So this area would be 36 over 2, or just 18. And this part over here, let's make this green. And let's get our dimensions correct from the start. So here it's 1, 2, 3, 4. So it's also 4 by 1, 2, 3, 4, 5, 6, 7. 4 by 7. So 4 times 7 divided by 2. So 28 over 2, or 14 units. And then our last little part, which is 8 by 2. 8 by 2 divided by 2 is just 8. Honestly, I just went like this and found 8. So now that we have all the pieces, I know my entire part is 72. So I can just do the area of the rectangle 72, and I'm just going to subtract the parts, the area of the parts that I found, minus 18 plus 14 plus 8. So 72 minus 40 leaves us with 32. The area of triangle ABC is 32 square units. And done. This one was fun. Hit pause and jot this one down into your notes. Alright, let's look at number 31. So we have some information here. We have the lengths of AE, EB, and AF already written out, as well as FC. And we have to be able to explain why EF, how do we know EF is parallel to BC? So this is the making me think of the side splitter. So let's actually prove if this is true. And what this is telling me is that if this is true, there's going to be a proportional relationship between this part to these two parts and these two parts, if this is true. So I could say that AE is to EB, as AF is to FC. So if this is true, then with side splitter, these two lines are parallel to each other. So we have 15, I'm going to just put in my numbers, over 27 is equal to 20 over 36. We'll do our cross products. 20 times 27 gives me 540. And if I did 15 times 36, I also get 540. So yeah, it works. So now it says I have to explain. So I can't just leave the work. So I have to really explain the side splitter theorem. All right. So according to side splitter theorem, if a line is parallel to one side of a triangle, how do I explain this? So it's intersecting the other two sides, the line. Okay, so it's parallel to the line and it splits. It intersects. The other two sides. So it's intersecting. You can see that this line intersects these two. So these are parallel, but this intersects these two. That's what I'm explaining. Then the line divides those sides proportionally. We tested the proportion, and it was verified and done. So that should be enough. So not only does my work show that I tested the proportion and we can see it, but I've also explained my work and explained that I understand that these two lines are parallel using the side splitter. Alright, so hit pause and jot this down into your notes. Similarly, you're going to have to do something like this in your explanation for this type of problem. Let's look at question 32, and the key to this one is don't copy down the wrong numbers and don't punch in the wrong numbers into the calculator, because it is a very simplistic problem, so there is so much room for error, for carelessness, and just rushing. So in this problem, and I say this from experience, we have a building. It's a pyramid, a rectangular pyramid. So there's a rectangular prism and then a pyramid on top. And we're trying to figure out how long it takes for a filter to clean the entire building. And it does that at a rate of 2,400 feet per minute. So we're going to find the volume of the building and divide by the rate. To do that, we're going to find the volume of the rectangle and add the volume of the pyramid and divide that by the rate. So mathematically, we know for a volume of a rectangle, it's length times width times height. And for a pyramid, it is 1/3 length times width times height. But also please note that the height is different for the rectangle and the pyramid. Because I made that mistake the first time I did this. And we have the rate already at 2,400 cubic feet. Okay, so let's start putting in the numbers, and that leads to part 2. Don't jot down the wrong numbers. So let's do the rectangle first. Our numbers are 38 times 22 times 15 plus 1/3. 38 times 15 times 12. Remember, they have different heights. All over 2,400. Okay, so we'll start with what should be the easy part. Let's just make sure we type in the right numbers. 38 times 22 times 15 gives me 12,540 plus, and in this case, because I don't want to mess this up, I like to put my 1/3 in parentheses times 38 times 15 times 12, and I get 2,280 divided by 2,400. Okay, 12,540 plus 2,280 is equal to 14,820 divided by 2,400, and that is equal to 6.175 feet per minute. So that's our rate, because remember we had our units were crossing out in this problem, so feet is gonna change. So okay, I still need to round this. That's the other place where we can make mistakes. So I told you we can make a mistake with the heights. We can make a mistake typing in numbers. We can make a mistake now with rounding because we want to round this to the nearest tenth of a minute. So this rounds to 6.2. How long does it take to clean? About 6.2 minutes. Now, why did I erase the other part? Because remember when we were talking about volume, we had cubic feet, and then we had the rate on the bottom, which was cubic feet per minute. So these cancel, and that's what left the minute. Okay, so I just wanted to make sure you saw where I got it with the canceling. All right, so here we have it. There's your final answer. And again, they're looking for process, but there are so many places where you could lose partial points. So just check and see if you have if you got 6.2 minutes and all your work shows that, give yourself a 4. If you made some type of calculation error like I did, the first time I did it, I used the same height for both 22. That would have deducted a point, at least a point, but that was consistent with the rest of my work. If you made an error, let's say there was a time when I was typing the calculator and I typed 32 by accident instead of 38. That would be a place where you would lose a point as well, even though you know how to calculate. But those are all like the little areas and complexities as they're trying to figure out what your score would be. So again, just take your time, be super careful, especially towards the end when you're the most tired and therefore the most likely to make mistakes. Hit pause and jot this down. Let's jump into number 33, where we have to prove that triangle ABC is congruent to triangle DEF. And they've given us a whole bunch of information over here. So let's jump in. We can see that both triangles, that's a given. They're both triangles, ABC and DEF. They show us that AB and BC are perpendicular, and DE and EF are perpendicular, and AE is congruent to DB, and that AC is parallel to FD. So let's start with our notations. So I have those two sides are congruent, AE and DB. And look at that EB in the middle. So that's going to be important that EB they both share that. When I'm looking at both triangles, they share that little segment. So that's going to be important because that means that EB, since I know it's going to be equal to itself, I know that AB is going to be the same size as ED because I'm adding the same EB to both AE and DB, and they're already the same size. All right, so what else? We know that we have perpendicular lines, so we have two right angles. So now so far I have sides and angles. That's going to be important because that's what I'm looking for when I'm trying to prove congruence. I'm looking at the sides and angles. So now I have sides that are congruent and angles. And we know that these two are parallel to each other, and that's going to be good because parallel lines make congruent angles, and we have some alternate interior angles over here at A and D. So now I see angles, sides, and angles. So that's going to be ultimately my argument. So I always start by just putting in all the information, and I'm looking to see what I can argue, and here it is. The whole thing about proofs is I don't just build, like there's this term build the plane while flying it. Like I don't come up with the reasons as I go. I really want to be thoughtful and intentional and plan it out beforehand. So I have a really clear argument because that's what you want to demonstrate, a very clear argument where things come together. So my goal is to really prove ASA in my proof. And I need a solid through line that I'm going to prove one point, then the next, and stay super organized. So again, just organizing my thoughts. For angles, I know I have alternate interior angles that are equivalent. I have the given sides are equivalent, plus I'm adding EB to both, so that's going to be super important. And then I have right angles that I know are also going to be equivalent. So we have all this great information, and now I can jump into the proof parts. Okay, so how do we put this in? Here's my statement. Here's my reason. I'm going to start by just going with the given first. The only time I'm going to write on the reason side first before the statement side. And I'm just going to rewrite all the stuff that was given to us. So yeah, all that information is up there. Yes, it seems like extra rewrite it, just do it, because it is part of our argument, and we're going to use some of this information because it's going to help, it's going to make our argument stronger. We need some of this evidence in there, supports us. So the first thing I'm going to go with is angle. So I want to prove that A and D are equivalent, and why? Because parallel lines cut by transversal creates alternative interior angles. And that's why I needed that AC is parallel to FD. I needed that in there so I can talk about those angles. Now I want to talk about sides. Obviously, before I can say that those sides are equal to each other, I got to talk about that EB part, because my given only says that AE is congruent to BD. So first I'm going to say the reflexive property, which pretty much says that segment is equal to itself, so that I could actually add it to AE and EB to BD. So now when I add the segment, the same size segment to both, now I know that those two segments are the same size. And that is part of the addition postulate. All right, so you can see how I needed 3 and 4 together. I needed 3 to come before 4 to talk about the side in that order. A lot of times kids will just go right to 4 when they're writing a proof, and they may forget to state that the EB is equal to itself. And that's how I know that segment, the whole segment AB, is equal to ED. Now I want to talk about the last angle. So first I have to start by saying that those two angles are right angles. And how do I know that they're right angles? Because in our given, we have perpendicular lines creating right angles. So now I can say, again, going with angles, that those two angles then have to be equivalent, because right angles are equivalent to each other. They're always 90 degrees. So again, you can see how those two, 5 and 6, go together. First, I say they're both right angles. How do I know? Because they're perpendicular lines. So even though it's like a does statement, I still have to add it in there. I am assuming nothing in my proof. I give all the evidence in there, and I'm using my given to support this claim. So let's check off. Now I can say that those two triangles are congruent because of ASA, and there is my solid through line. So I'm going to hit pause so you can jot this down, but I do really want you to know how all of it began with taking what was given and notating it, and then I'm really looking at my sides and angles to prove triangle congruence, because I know it has to be one of those theorems, and in this case it was angle side angle, and I could see it. Then I start pre-planning. How do I make a through line to prove A, S, and A? That is my goal, and I did that in my statement and reasoning. All right, hit pause and jot this down into your notes. All right, we have some more right triangles, so some more trig. So this one I want to read through very carefully. We have a diagram where a boat is at point A. Here's our little boat, and it's traveling towards the waterfall. And it's a vertical drop. There's a waterfall, it's 188 feet high, and there's an angle elevation from where the boat is up is 15 degrees. Okay, that makes sense. So let's get to the after. After the boat travels towards the falls, it stops over here, there's an angle of elevation of 23 feet. So I want to put that, I'm going to put it actually in red. 23 degrees over here. We want to know and state the nearest foot the distance of A to B. So I want to know this part here. So based on what we want, this is the part we want to know. Do we have enough information here? So we can figure out this whole part here. I have enough information for that because using my 15 degrees, I know I can see the 180, so I have an opposite here. And I have an adjacent. So I have an opposite and an adjacent. So that's my TOA. I'll put it in black. So my tangent 15 is going to give me my opposite over adjacent, or 10. 15 is equal to 188. And the adjacent, this is what I want to know, that's my x. Okay, so we're gonna solve for this one first. And because I really want to know what my x is, and if we were to cross, remember how we talked about before, like that swap and why it happens. So x is equal to 188 over tan 15. That's my equivalent expression. I don't want to call it a swap. I want to call it an equivalent expression. Okay, so let's put it and use our calculators now. We have 188 divided by tan 15, and we get x is equal to 701,625, and this would be feet. So that's the entire length of from boat A all the way to the waterfall. Okay, from A to the waterfall. But I only want to know AB. So I'm going to do the same sequence again, this time from point B. So now we're going to do tan 23 is equal to 188 over x. Same thing. Let's move this up. We're going to do x is equal to 188 divided by tangent 23. And that is equal to 442,900 feet, and that is from B to the waterfall. So if I just want A to B, I'm just going to do 701.625 minus, so AB is equal to this minus the 442,900. I'm just going to subtract those two, and since we have a calculator, why not? And we get 200. The distance of AB is 258.720. I'm getting 5 here on this part. Okay, and they want us to round to the nearest foot. So this means I'm going to round up. So the distance from AB is about 259 feet. All right, so there we have it. So again, all I did was find the entire distance was the 701, and then we found just this part over here was 442.9, and then I just subtracted to figure out this little section over here. All right, hit pause and jot this down into your notes. So let's look at our very last part, part 6. So this is our 6 credit problem. There are going to be multiple parts here, and we want to make sure that we're really paying attention to our level of precision and have a good plan. So let's move it up a little bit. We have triangle Joe, and they're giving us the coordinates for the vertices for JOE, and we need to first be able to prove that JOE is isosceles, which in other words, I can prove by definition if two sides are congruent. So being that they've given us coordinates, this is telling me more likely that I'm going to need to graph it. They do give us graph paper on the next page. That's optional. You could also just sketch an actual graph. So what my plan is going to be here is I'm going to plot the coordinates, and I'm going to calculate the side lengths, and I'm going to look to see if two are congruent. Okay, now this would be easy if everything's a right angle. If not, I'm going to use some triangles to help do this. So going to move over. Actually, let's make this a little bit bigger on this end here. I've already just plotted JOE so you can actually see it. I can see this does not have any easy size. I can't just, they're not vertical or horizontal. So what I'm going to do instead is let me connect these points. And what I'm going to do instead is I'm going to create a rectangle around my triangle. Okay, and the reason I'm going to do that is because I'm going to figure out, using Pythagorean theorem, the length of the hypotenuse. Now every single side for my triangle is a hypotenuse because I've created right triangles. Okay, so let's start, and I'm going to just label these little triangles A, B, and C so I can figure out the side lengths. Alright, so I'm going to start with triangle A. And to figure out JO, this is to help me in triangle A, and this is going to help me figure out, actually I want in black, I want to figure out the length of JO. So my dimensions for this triangle are 2 and 1, 2, 3, 4, 5, 6, a 2 by 6 triangle. So Pythagorean theorem, 2 squared plus 6 squared is equal to C squared, which is what I want. That's my JO. So I have 4 plus 36 is equal to C squared. 40 is equal to C squared. So C is equal to the square root of 40. So JO is equal to the square root of 40. And I don't want to lose anything. Again, attention to precision. So there we go. I have my first side length. Now let me go to triangle. Actually, I want to go to triangle. Yeah, let's just do B. I'll go to B. So 1, 2, 3, 4. So this is the right triangle of 4 by, what's the other leg? 1, 2, 3, 4, 5, 6, 7, 8. 4 by 8. So this is so I can find the length of OE. So I have 4 squared plus 8 squared is equal to C squared. 16 plus 64 is equal to C squared. 6 plus 64 is 70, 80. Okay, so 80 is equal to C squared. Square root 80 is equal to C. Side OE has a length of square root 80. For now, this is good. Now I have 2 of the sides. And now let's do C. Looking at triangle C. So I can find out from J to E. Because so far, those 2 sides aren't congruent. And for this one, my dimensions are 2 by 1, 2, 3, 4, 5, 6. And we've seen that triangle before. We already had a 2 by 6 here. Now we have another 2 by 6 here. So I can literally just recopy the same thing. 2 squared plus 6 squared is equal to C squared. 4 plus 36 is equal to C squared. 40 is equal to C squared. Square root 40 is equal to C. JE is equal to square root 40. Now I got what I wanted. I have 2 sides that are equivalent. So that is the information that I needed. And again, I could have just sketched it in that space, but this cleanly shows how I was able to prove it. So what am I going to write over here? So I had JO and JE. Triangle JOE is an isosceles. God, I spell it wrong every single time, even when it's literally on the page. triangle. So J O and J E have, how do I want to put this, are both have a length of square root 40. And then OE has a length of square root 80. Given two sides are congruent, by definition, triangle JOE is, and I I made sure that I looked at it because literally it's right there, and I isosceles triangle. So boom, that is the first part. All right, there is a part 2, but hit pause, jot this part down into your notes. All right, let's look at the second part for this question. We have point Y is at 2, 2, is on OE, and we need to be able to prove that JY is perpendicular to OE. So let's just think about that for a minute. How would I prove that? Well, one, if to prove perpendicular, I would have to show the slopes are opposite reciprocals. And then to choose it was a bisector, I'd have to really prove that OY is the same size as YE. So let's just put that point in there. So here is point 2, 2. Here's Y. Here is JY. So let's make this a little bit higher so you can see it. So one, I need to be able to prove that this is perpendicular, and I need to be able to prove that these two sides would be equal to each other on my graph. All right, so let's start with perpendicular. And even though on my graph I can see if I could find the slope for this line, because I know I'm going down 4 and over 8. I know that the slope for OE is down 4 over 8 or negative 1/2. But I have to be able to demonstrate that reasoning. I need to be able to prove it. So I'm going to use, let's use our most trusty formula here, y2 minus y1 over x2 minus x1 to figure out slope. And I'm looking at these 2 points here from O to E. Okay, so now I can do 0 minus 4 over 6 minus 2, which is the same as negative 4 over, so 6 minus 2 would be 8, which is again negative 1/2. So we proved it. Now, so what would the slope have to be if it was the opposite reciprocal for JY? I have to be able to prove that it would be positive 2 over 1 or just positive 2. So I'm going to do the same thing for J and Y. So I did the first points. The first one with just J with O and E. And now I'm going to do it for J and Y. And so here's J, and I'm going to put Y in there as well. Okay, so I'm going to decide these are my ones, this is my 2. So I have, oops, I like to rewrite the whole formula. So 6 minus 2 and 4 minus 2. And that gives us 6 minus 2 is 4. 4 minus 2 is 2, which simplifies to 2 over 1 or 2. So boom, they are perpendicular. The slopes are opposite reciprocals. MOE is equal to -1/2. MJY is equal to +2. I'm going to put this in parentheses. So I just proved that JY is perpendicular to OE. Alright, I want to keep this super clean and easy, so let's hit pause and jot this part into our notes. Alright, here's the next part. I need to be able to prove that on this line, this point here is halfway, that these two segments are the same size. So what I'm going to do, and luckily I just have a pencil here so I can just erase this part here, is I just want to look at OY and make a triangle, and YE and make another triangle, so I can figure out the distances. So I kind of just drew them at top so we can just see, because there's a lot going on my page, and I thought this was the simplest way, and I could look at the dimensions. So just looking here, I know that this is a 2 by 4 triangle, and the same thing is true here. This is a 2 by 4 triangle. And so I can just use, literally we're going to use the same formula. 2 squared plus 4 squared is equal to c squared. So 4 plus 16 is equal to c squared. 20 is equal to c squared. Square root 20 is equal to c. Square root 20 is equal to OY. And the same thing is going to be true of this side, because it's the same dimensions. And therefore, OY is congruent to YE. And now I can say JY is a bisector of OE because OY is congruent to YE. Both have a length of square root 20. And done. So again, there's a lot going on this page, but there's a lot going on because this is a 6-point problem. So I wanted you to be able to see where I'm getting these values and these numbers from, so you could actually see it. So we can actually just see them happening in here. And even if I want to in my notes, I could also just show the 2 and the 4 and the 2 and the 4, so you can figure out the values of these parts here. And the other way you really could have just seen is I would have been looking for, if OE is square root 40, then I knew I was looking for half of that. All right, and that's it for this exam. This is the last part. Again, I try to keep my notes as clean and neat as possible so that I can follow along, because that is your goal. Your goal is not to just be able to know it in your head. Your goal is to be able to demonstrate that you know it. And so even though you might think, well, they know what I mean by it's a bisector. They know what I mean by this is a right angle, and they're all equal to each other. Of course, the person grading your test knows that. They're looking to see if you can demonstrate that. So it's not about what you know, it's about what you can prove on that page. So let's leave it all out on the page for them to see. All right, hit pause so you can jot this part down into your notes. All right, so now you've gone and done the entire exam. I retaught myself a ton of geometry to do this video because I actually haven't taught geometry to students. I've made materials, but I've never actually had to teach a class, so being able to take a Regents was a great refresher for me, and it makes me way more confident about videos I'll make in the future for geometry. So with that, let's talk about the conversion chart. Now, this was a Common Core test in June 2024. The new Next Gen exam is coming out in June 2025. So there might be some minor changes, but not too many. It will be the same number of questions, I believe, and most of the content will be the same. As for scoring, you had 24 multiple choice, each worth 2 points, and we saw the 2-point questions, the 4-point questions, and the 6. So you would add up, you score yourself using this video, add everything up together, and that will give you your raw score. Now, using this chart, you'll be able to do the conversion. So if, for example, just to get level 3, the lowest score of a 65, just to get to that, you would need 30 raw points, and that will be the sum of all your constructed points as well as your multiple choice points. Now, for those who are pushing beyond that, just so you can see what the cutoffs are, for a 2, you need at least 21 points. To get a 3, you need at least 30 points. To get a 4, you need at least, here you go, at least 55 points. And to get a 5, you would need at least 64 points. All right, so go back over the video, look and see how many points you would have gotten, and challenge yourself. Look and see what are you aiming for the actual Regents. How can you get at least 2 or 3 more points on the exam? And on this video, just ask questions, put things down. If you had different strategies, name them as well. But I really hope you found this helpful, and I hope to see you in some more geometry videos in the future. But not for you, because you will be on your way to Algebra 2. That's all for today in this video. I wish you the best of luck on the Regents. And that's it. Be well, Math Marbles. Later.